think there's been a sea change in the last just several years. 50 years ago, there was a congressional hearing, and it was coming out of Project Blue Book.
Michio Kaku, the renowned theoretical physicist and futurist, recently unveiled a list of 15 compelling and potentially terrifying discoveries in the icy wilderness of Antarctica. This video explores these revelations, from ancient viruses trapped in ice to the instability of the Antarctic ice sheet, each of which poses unique challenges and illuminates different aspects of our planet's past, present, and potential future.
And so we now have a sea change. A center of gravity has changed with regards to looking at these objects.
Number 1. Ancient viruses revealed in ice. As scientists drill down into the miles-thick ice sheets of Antarctica, they aren't just studying the Earth's climatic past, they're also unlocking a Pandora's box of ancient viruses, encapsulated and preserved in the ice for millennia. This treasure trove of prehistoric microbiology provides a unique window into the viral world of the ancient past, offering scientists an unprecedented opportunity to understand how these microscopic creatures have evolved over the course of Earth's history. In these ice cores, every layer corresponds to a different era in Earth's history, frozen in time, and these ancient viruses are essentially stuck in that moment. The deeper scientists drill, the further back in time they go, sometimes reaching back hundreds of thousands of years. These are viruses that modern life has not encountered, and as such, we have no natural immunity against them. The discovery of these ancient viruses raises fascinating questions about the history of life on Earth, the nature of viruses, and our planet's past environments. But it also presents significant concerns about the potential impacts on present-day ecosystems and human health. As global temperatures rise and these ancient ice reservoirs begin to melt, there's a risk of these prehistoric viruses being released back into the environment. Given that these are pathogens that humanity hasn't encountered for thousands, if not millions of years, the potential implications for global health could be significant. Furthermore, our understanding of these viruses is still in its early stages. Scientists are grappling with challenges posed by the extremely delicate nature of these virus particles and the technological limitations that exist in decoding the information they contain. This discovery emphasizes the urgency of climate action. Every piece of the ancient ice that melts could mean the loss of an invaluable scientific resource, a direct link to our planet's history, and the potential introduction of ancient viral entities into our modern world. The intricate interplay between scientific discovery, historical investigation, and urgent, real-world implications make this one of the most compelling and terrifying of the Antarctic discoveries. Number 2. Rapid ice melting. Antarctica, the world's southernmost continent, is experiencing rapid ice melting at an alarming rate. According to Kaku, recent studies show that the rate of ice melt has tripled in the last decade, with more than 200 billion tons of ice being lost to the oceans each year. This unprecedented melting is primarily driven by the warming of the planet due to anthropogenic climate change. The impacts of this phenomenon are multifaceted. The melting of the Antarctic ice is leading to an increase in sea levels worldwide, threatening low-lying regions and islands. By the end of this century, if the current rate of melting continues, global sea levels could rise by more than a meter, inundating coastal cities and displacing millions of people. Another impact of rapid ice melt is its influence on global weather patterns. The ice of Antarctica helps to regulate the Earth's climate by reflecting sunlight back into space. The loss of this ice diminishes the planet's albedo or reflectivity, leading to further warming in a dangerous feedback loop. The ice shelves of Antarctica also act as barriers, restraining the flow of land-based ice into the ocean. As these shelves thin and collapse due to warming, they can accelerate the flow of glaciers into the ocean, further driving sea level rise. The alarming rate of ice melt in Antarctica is a stark reminder of the urgency of tackling climate change, a clear manifestation of the effects of global warming and a worrying precursor of what the future may hold if global carbon emissions continue at their current pace. Number 3. Hidden ecosystems beneath the ice. Antarctica is not just a barren, icy wasteland as it often appears on the surface. Kaku points out that hidden beneath the continent's thick ice lies a diverse, complex, and largely unexplored ecosystem teeming with life. Through the drilling of ice cores and the use of advanced imaging techniques, scientists have found lakes and rivers flowing beneath the ice. These subglacial ecosystems are home to a range of unique and hardy organisms. These organisms, including bacteria and other microbes, have adapted to live in extreme conditions of pressure, low temperatures, and total darkness. And they utilize chemicals like methane and iron for energy in the absence of sunlight for photosynthesis. The discovery of these ecosystems has vast implications. It expands our understanding of the limits of life on Earth and the range of environments in which organisms can survive. And this insight has intriguing implications for the search for life on other planets, as it suggests that life may exist in environments previously deemed uninhabitable. On the other hand, there are concerns that drilling and exploration activities might inadvertently introduce foreign organisms that could disrupt these fragile ecosystems. The balance between scientific discovery and preservation of these untouched environments is a complex issue. The uncovering of these ecosystems beneath Antarctica's ice opens up a new frontier in science, providing a deeper understanding of life's resilience, but also poses profound questions about our responsibility to protect these hidden and fragile worlds. Number 4. The impact of climate change on Antarctica's wildlife. Climate change's impact on Antarctica extends beyond its melting ice shelves. It also directly affects the continent's unique and diverse wildlife. According to Kaku, rising temperatures and shifting sea ice patterns are disrupting the delicate balance of life on this remote continent. One iconic species particularly affected is the emperor penguin. These creatures rely on the sea ice for breeding and foraging for food. With the sea ice disappearing earlier each year, many colonies are finding their breeding sites reduced or eliminated. Current estimates predict a 50% decline in emperor penguin populations by the end of the century if sea ice loss continues at its current pace. And then there's krill, tiny shrimp-like crustaceans that form the base of the Antarctic food web. They depend on the under-ice algae for sustenance during their larval stage. The reduction in sea ice and the subsequent decrease in algae is likely to have a cascading effect, impacting not just krill but all species that rely on krill for food, including whales, seals, and various species of penguins. Furthermore, warmer ocean temperatures affect the abundance and distribution of fish species, which can have significant impacts on larger predators. Also, an increase in ocean acidity due to higher carbon dioxide levels threatens shell-forming organisms and disrupts the overall marine ecosystem. This stark picture of Antarctica's wildlife under stress from climate change is a chilling reminder of the intricate ties that bind living creatures to their environment and the far-reaching impacts of our actions on even the most remote corners of our planet. Number 5. Unprecedented methane release. Kaku's announcement also highlights an alarming discovery: the unprecedented release of methane trapped in Antarctic ice. As the Earth's temperature rises and ice melts, methane, a potent greenhouse gas trapped in ice for thousands of years, is being released into the atmosphere. The worry is that this could lead to a positive feedback loop, a runaway effect. As the planet warms and ice melts, more methane is released, which in turn contributes to further warming, leading to more melting and more methane release. And methane is about 30 times more effective at trapping heat in the atmosphere than carbon dioxide over a century, which makes its release from melting ice a severe concern for climate scientists. The amount of methane stored in the Antarctic ice sheet is vast, and even if a small percentage is released, it could significantly accelerate global warming. Research into this is still in the early stages, and scientists are not yet sure of the extent of the impact of methane release on future warming. However, the potential of this feedback loop makes it one of the most terrifying aspects of climate change. This discovery underscores the urgency of mitigating climate change. It is crucial to limit global warming and prevent potential tipping points beyond which
the methane then heats the atmosphere, contributing to global warming.
Runaway effects like massive methane release could drastically alter our planet's climate system. Number 6. Fossil records indicating past tropical climate. While Antarctica is currently the coldest continent on Earth, Kaku reveals that it was not always this way. The fossil record found within Antarctica's rock and ice provides compelling evidence that the continent once experienced a tropical or temperate climate millions of years ago. These fossils include remains of ancient ferns, palm trees, and even dinosaurs, suggesting that Antarctica was once teeming with life. The presence of such fossils indicates the continent was once located in a much warmer region, supporting the theory of continental drift. And from a climate perspective, these findings provide essential clues to understanding Earth's past climatic conditions. The fossils suggest periods of elevated atmospheric carbon dioxide levels leading to a greenhouse effect that warmed Antarctica. Such warming caused major changes in global ocean circulation, contributing to a different climate regime compared to today's world. These discoveries offer an important perspective on our planet's climate system's complexity and dynamic nature. They highlight how dramatically and completely climatic and ecological conditions on Earth can change. Number 7. Evidence of cosmic particles. One of the more otherworldly discoveries Kaku discusses is the detection of cosmic particles in Antarctica. Scientists have detected high-energy neutrinos, subatomic particles that travel through space in the Antarctic ice. Neutrinos are nearly massless, chargeless particles that can pass through most matter unaffected, making them extremely difficult to detect. However, a massive detector buried in the Antarctic ice known as the Ice Cube Neutrino Observatory has managed to detect these elusive particles. The observatory uses the clear, deep ice to look for tiny flashes of light produced when neutrinos interact with the ice. These high-energy neutrinos are believed to originate from some of the most violent and energetic processes in the universe, such as exploding stars, supernovae, gamma-ray bursts, or even black holes. The detection of these particles in Antarctica provides valuable insights into these extreme cosmic events and helps scientists explore some of the more fundamental questions about the universe's nature. This discovery exemplifies the multidisciplinary nature of Antarctic research and how this remote, icy wilderness plays a crucial role in advancing our understanding of the cosmos. It brings to light the interconnectedness of the universe and our planet's place within it. Number 8. Ice-free areas. Among the discoveries Kaku announced, one surprising revelation is the existence of ice-free areas known as Antarctic oases or polynyas within the continent itself. These regions void of surface ice despite sub-zero air temperatures mystify scientists. Polynyas are areas of open water or thin ice that appear within thicker ice. They occur due to warm upward currents or high wind activities that prevent new ice from forming. They serve as crucial areas for heat exchange between the ocean and atmosphere, impacting weather patterns and oceanic circulation on a global scale. Notably, these polynyas are thriving hotspots for biodiversity. The open water allows sunlight to penetrate the ocean, stimulating the growth of phytoplankton. These tiny organisms form the base of the food web, attracting a plethora of marine life, including krill, fish, birds, and mammals. Therefore, these ice-free areas indirectly support vast colonies of seals, penguins, and whales. However, climate change is influencing the size and prevalence of these polynyas. A larger, more frequent polynya could potentially disrupt the Antarctic ecosystem and affect global weather patterns and ocean currents. Number 9. Unexplained radio signals. Another enigma in Kaku's list is the detection of unexplained radio signals emanating from the icy depths of Antarctica. Scientists are using a giant balloon with an antenna hovering high above the Antarctic ice to catch these ultra-high-energy particles and the radio signals they generate on impacting the ice. But the origin of these signals remains a mystery, stirring a lot of excitement and speculation in the scientific community. Hypotheses include neutrinos with energies a million times greater than what current physics can explain, dark matter particles, or entirely new phenomena we have yet to understand. Though the source and significance of these signals are yet to be ascertained, their existence opens up a new avenue of scientific exploration. It offers an opportunity to potentially uncover new particles, forces, or laws of physics, making this one of the most exciting discoveries from Antarctica. Number 10. The impact of ozone layer depletion. The Antarctic region is home to the notorious ozone hole, an area of significant ozone depletion in the stratosphere. This environmental concern, which Kaku highlights, stems from the excessive release of chlorofluorocarbons, CFCs, and other ozone-depleting substances. Although the Montreal Protocol has significantly reduced these substances' production, their impact on the ozone layer persists due to their long atmospheric lifetime. The depletion of the ozone layer has serious consequences, both environmental and biological. Increased ultraviolet UV radiation reaching the Earth's surface affects Antarctic ecosystems. Phytoplankton, the base of the marine food chain, are particularly vulnerable to high UV levels, impacting the whole food web. And what's more, ozone depletion influences climate patterns. It causes cooling of the stratosphere, altering wind patterns and potentially influencing weather and climate conditions far beyond the Antarctic region. Significantly, the ozone hole over Antarctica demonstrates the potential for global human-induced changes to dramatically affect our environment. It serves as a stark reminder of the delicate balance within Earth's systems and our capability to disrupt it. Number 11. Unknown microbial life. Antarctica, with its harsh and extreme environment, is a surprising haven for life. Kaku's revelations indicate the existence of unknown and diverse microbial life within the continent. Microorganisms have been found in the continent's most extreme environments, the deep sea, beneath the ice cover, and even within the ice itself. These microbes are extremophiles, organisms that thrive under conditions hostile to most life forms. They have unique adaptations that allow them to survive in cold, dark, and isolated environments, often reliant on chemosynthesis rather than photosynthesis. The discovery of these microorganisms expands our understanding of life's adaptability and resilience. It raises fascinating questions about the possibility of life on other planets with similar harsh conditions, such as the icy moons of Jupiter and Saturn. Moreover, these microbes might hold keys to novel biochemical processes and compounds. They are a valuable resource for biotechnology and medical research, providing new avenues for discovery and innovation. However, with the possibility of life comes the responsibility to protect it. Therefore, ensuring the preservation of these unique organisms during human exploration and exploitation of Antarctica is of paramount importance. Number 12. Rising sea levels. Rising sea levels have been a significant concern for scientists studying climate change, and Kaku's announcements have given this topic additional weight. Antarctica's ice reserves hold a vast amount of frozen water. If all of this ice were to melt, sea levels worldwide could rise by about 60 meters, a catastrophic amount that would inundate coastal cities and displace hundreds of millions of people. Currently, Antarctica loses ice mainly through two processes: melting from the base of ice shelves and calving of icebergs. And studies suggest that both of these processes have accelerated in recent years due to global warming, contributing to sea level rise. Of particular concern is the potential for rapid ice loss from the West Antarctic ice sheet, which could add significantly to sea level rise. And this rise in sea levels is not a distant theoretical risk, it is already happening. The rate of sea level rise has nearly tripled from the 20th century average, and low-lying island nations are experiencing increased coastal erosion and saltwater intrusion into their freshwater supplies. Rising sea levels pose a substantial threat to human societies, especially those situated in coastal areas. This threat makes it crucial to reduce greenhouse gas emissions and limit global warming to levels that will prevent the most dramatic sea level rise scenarios. Number 13. Mysterious underwater mountains. In the deep icy waters off Antarctica, Kaku highlights the discovery of mysterious underwater mountains, or seamounts. These geological formations rise from the ocean floor and can reach heights comparable to Earth's highest mountains. Seamounts are formed by volcanic activity and are found throughout the world's oceans. However, those discovered near Antarctica are particularly intriguing due to their remoteness and the unique ecosystems they support. These underwater mountains are biodiversity hotspots, providing habitats for a diverse range of marine life, including numerous species new to science. In addition to their ecological importance, seamounts offer valuable insights into Earth's geological history. They can help scientists understand the dynamics of plate tectonics and the processes that have shaped our planet's surface over millions of years. These discoveries again emphasize Antarctica's role as a frontier for scientific exploration, offering new insights into our planet's geology and the remarkable diversity of life that exists even in its most extreme environments. Number 14. Signs of ancient human life. Michio Kaku's intriguing announcement about the possible evidence of ancient human life in Antarctica opens up a realm of fascinating speculations and hypotheses. The frigid, remote Antarctic landscape as we know it today appears inhospitable to human life, making the notion of past human habitation seemingly implausible. However, the discovered artifacts, including primitive tools and indications of human activity, are thought-provoking. Although these findings are contentious and the subject of an ongoing debate within the scientific community, they could, if validated, lead to a dramatic reinterpretation of human history. Any evidence of ancient human life in Antarctica would necessitate a reassessment of our understanding of early human migration patterns. Conventional historical and archaeological consensus maintains that early human migrations from Africa primarily spread across Eurasia and into the Americas, with no known route leading to Antarctica. And so unearthing signs of ancient human life in Antarctica would imply a previously unknown complexity to these migration patterns. It would require a profound reconsideration of our ancestors' abilities to adapt and survive in extreme conditions, significantly earlier than what was previously believed. It raises questions about how these humans could have journeyed to such a remote and hostile landscape and how they managed to sustain themselves. The possibility of ancient human life in Antarctica also highlights a crucial fact about the continent: its dramatically different past. Today's icy, inhospitable Antarctica was once, millions of years ago, a temperate landscape teeming with life. The continent was part of the supercontinent Gondwana, positioned further north and featuring a much warmer climate. Fossil evidence indicates the past existence of lush forests and a variety of fauna, including dinosaurs. If early humans had indeed settled in Antarctica, their presence likely coincided with a period of climatic and environmental change as the continent drifted southwards and its climate cooled. Understanding how these humans might have responded to these changes could offer important insights into human adaptability and resilience in the face of shifting climates and environments. Yet these theories remain largely speculative at this stage, given the scarcity and disputed nature of the evidence. Archaeologists and anthropologists need to continue their explorations, scrutinizing any findings with rigorous scientific methods to ensure their validity. And whether ultimately confirmed or debunked, the ongoing investigation into the signs of ancient human life in Antarctica underscores the continent's value as a scientific frontier. It reveals the endless possibilities that await discovery in this frozen wilderness, promising exciting insights into our planet's past and our species' remarkable journey. Number 15. Antarctic ice sheet instability. Antarctica, the Earth's southernmost continent, harbors about 90% of the world's ice. The Antarctic ice sheet, divided into the east and west Antarctic ice sheets, is a colossal frozen reservoir. If melted entirely, it would raise global sea levels by a staggering 60 meters, a catastrophe that could displace hundreds of millions of people worldwide. Understanding the stability of this ice sheet is therefore crucial for predicting future sea level rise. The recent discovery that Kaku highlights pertains to increasing concerns over the Antarctic ice sheet's stability. This topic has garnered much attention as human-induced climate change continues to accelerate. The fundamental fear is that rising temperatures could cause an irreversible meltdown of the ice sheet, leading to significant global sea level rise. The West Antarctic ice sheet, resting largely on bedrock below sea level, is especially vulnerable. It is exposed to warm ocean currents that are eating away at the ice from below, causing it to lose mass. Several significant glaciers in this region, such as the Pine Island and Thwaites glaciers, are showing signs of instability as well. These glaciers are retreating rapidly, and their collapse could potentially lead to an unstoppable process known as marine ice sheet instability. This phenomenon, once triggered, could cause a domino effect, leading to the disintegration of the entire West Antarctic ice sheet. If this occurs, it would result in a global sea level rise of more than 3 meters. And traditionally, the East Antarctic ice sheet was thought to be more stable due to its larger size and because most of it rests on rock that is above sea level. However, recent studies have suggested that it might be more vulnerable to melting than previously thought. There's evidence that parts of the East Antarctic ice sheet have melted in past warm periods, contributing to sea level rise. And some areas like the Totten Glacier are also being eroded by warm ocean currents similar to the glaciers in West Antarctica. This erosion could potentially expose more ice to melting, adding to global sea level rise. These discoveries concerning the instability of the Antarctic ice sheets are a significant cause for concern. They underline the urgency of mitigating climate change to prevent potential tipping points in ice sheet stability. However, predicting the exact response of the ice sheets to future warming is challenging due to the complex interplay of factors involved, including atmospheric and ocean temperatures, global and regional climate patterns, and the geological and physical properties of the ice sheets themselves. Current research efforts are thus focusing on improving our understanding of these factors to refine predictions and devise effective climate policies. The Antarctic ice sheet's instability and its potential impact on sea level rise highlight the stark reality of climate change and the urgent need for global action to address this existential crisis.